ஹலோ சித்தார்த்தன் சார் கேக்குதுங்களா? இப்போ அவங்களுக்கு இவங்களுக்கு இல்ல இல்ல இதுல அதுல கேட்கணும்ல சார். அதில் கேட்காது, மொபைலில் தான் தரும். அதில் கேட்குது. இப்போ ஹலோ ஹலோ கேக்குதா? இல்லை, நான் அன்மியூட் பண்ணிட்டேன். ஹலோ 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 கேக்குதா? ஹலோ ஆடியோ ரைட் ஓகே.
Good morning to all.
சார் நீங்க மைக் வேணாம், மைக் தான்.
Hello.
மைக் வேணாம் சார், மைக் தான் பேசுங்க. அது ஆஃப் பண்ணுங்க.
Good morning to everyone present here.
உங்களுக்கு கேட்கும். நீ ஹெட்செட் தானே போட்டிருக்கீங்க? சரி ஓகே ரைட். நீ ஹெட்செட் எல்லாமே பேசிக்கணும். உனக்கு ஹெட்செட் வேணுமா வேண்டாமா?
Headset எல்லாமே பேசிடுவோம்ல எல்லாரும். Good morning to all. Good morning to everyone present here. Welcome you all for the third international conference on science and humanities, building science and mechanical engineering.
Good morning to everybody. Okay, can you hear me?
Good morning, sir.
Good morning,
sir.
morning.
Sir, please wait for 2 minutes, sir. Please wait for 2 minutes.
Okay, I'll wait. Yeah, it is audible to me. Huh.
We acknowledge your presence in our midst and seek your guidance as we embark on this journey of International Conference on Science and Humanities, Building Science and Mechanical Engineering. We thank you for the gift of knowledge and understanding that allow us to reach into the mysteries of science and humanities. We recognize the beauty and complexity of your creation, reflected in the wonders of building science and mechanical engineering. Bless this conference, its organizers, keynote speakers, Dr. A. Rajadurai, Dr. Subhas, Dr. Pradeep, and all the participants. Bless all of them and their family too. Give them wisdom to inspire others and youth to make a great society. As we research into the realms of science and humanities, may we never lose sight on the ethical we bear towards the future generations. May our pursuits be driven not only by intellectual curiosity, but also by a desire to serve and uplift the humanity. We entrust this conference into your loving hands, knowing that with you all things are possible. May your grace be upon us throughout these deliberations, guiding our thoughts, words, and actions. In your holy name we pray, Amen. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread. Forgive us our trespasses, as we forgive those who trespass against us. And lead us not into temptation, but deliver us from evil. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen.
Please take your seats. Thank you, sister, for that soulful prayer. Now, I would like to invite Mr. R. Siddharthan, HOD of Mechanical Engineering, JP College of Engineering, to give welcome address.
Very good morning to everyone present here. It gives me an immense pleasure for giving the welcome address to the 3rd International Conference on Science and Humanities, Building Science and Mechanical Engineering. So in this occasion, this is the 3rd International Conference we have been organizing. So we start this international conference with the blessing of our founder father, Reverend Father J. Arul Raj. And I invite our administrator, Reverend Sister B. Hamlet, for accepting and gave confirmation for conducting this 3rd international conference. So in this occasion, I welcome our administrator, Reverend Sister Hamlet. I welcome you, sister. And I welcome our beloved principal, Dr. M. Rajkumar sir. He continuously motivated us for organizing this 3rd international conference along with mechanical, civil and SNH department. Sir has given more instruction and information about smoothly organizing the international conference. In this occasion, I welcome our beloved principal, Dr. M. Rajkumar sir. I welcome you. And I welcome our keynote speaker, Dr. A. Rajadurai sir, eminent professor, Madras Institute of Technology, Krompet, Chennai. Sir has been continuously giving the keynote address. This is the 2nd time sir is giving the keynote address to our institutions. So in this occasion, I welcome our keynote speaker, Dr. A. Rajadurai sir. I welcome you, sir.
Thank you very much.
And I welcome the 2nd keynote speaker, Dr. Subhas Thanapan, professor in Department of Civil Engineering, Kafa University College, Republic of Ghana, West Africa. In this occasion, I welcome you, sir. And I welcome the 3rd keynote speaker, Dr. Pradeep, IQE PLC Process Engineer from United Kingdom. So in this occasion, I welcome you, sir. And I welcome all the other college participants and research and development cell member for attending this 3rd international conference. It will be an eye-opener to all the participants. And I welcome all the heads of the departments from JP College of Engineering, and I welcome staff members from SNH, Mechanical Engineering and Civil Engineering, and other department faculty members. And I welcome all the students from JP College of Engineering for attending this 3rd international conference. Finally, I welcome you all once again. Thank you. Before going to hand over the session to Dr. A. Rajadurai sir, I just give an introduction about our keynote speaker, Dr. A. Rajadurai sir. Dr. A. Rajadurai sir is currently working as a professor in Madras Institute of Technology, Krompet, Chennai. Sir has completed his BE Bachelor of Engineering in Mechanical Engineering from Government College of Engineering, Salem, and he pursued his Master degree in Metallurgy from PSG College of Technology, Coimbatore, and Sir has completed his PhD from Indian Institute of Science, Bangalore. He was the head of the department in production technology in the year 2007 to 2011. He was the director of Center for Affiliation Institution since 2008 to 2015. He was the dean in Madras Institute of Technology, Crumpet from 2015, about 9 years. He has been working in Anna University, Chennai since 1987. He has 35 years of teaching experience. He was the senior research fellow in Department of Atomic Energy, and he was the research associated in CSIR New Delhi, and Sir has published more than 100 journals so far, and 9 conference proceedings, and 2 book chapters, 2 editorial board member, and 1 reviewer. Sir, citation is 4,742. It's really a big number of citation, and H index is 32, I index is 59, and Sir received many projects from DST and central governments. So I highlight only 2 projects now: coating of cutting tools and performance evaluation, and ultrasonic dispersion of silicon carbide in aluminum silicon carbide composite. He is a member of Indian Institute of Welding, and he received many patents from Indian government. So with these words, I welcome our keynote speaker, Dr. A. Rajudhari sir. Sir, I welcome you, sir, and I hand over the session to you, sir.
Thank you. Thank you very much. Okay, thank you very much for your nice words. So I will go for my presentation now. Okay. So shall I? You could see me now. Hear me?
Yes, sir. Yes, sir. Sir, your voice is visible, sir. Your voice is audible, sir.
Hello? Am I audible?
Yes, sir. Yes, sir.
Yes, sir. You are audible, sir.
Yes, sir.
Yeah. Okay, now shall I go for sharing my slide? Okay.
Okay, sir.
Sure, sir.
Okay, sir. You can proceed.
Could you able to see my face now?
Yes, sir. Your face is visible,
Yes,
sir.
sir, you are visible.
Yeah, okay. So thank you for your very nice words. Okay, but I could not able to see my sharing option. Whether you have to enable it. Hello. Could you able to see and then hear me?
Yes, sir.
Yeah, okay.
Sir, can you send your PPT?
Are you able to see my title? Hello?
Yes, sir.
Yeah, could you able to see my first page of Hello?
Right now sharing your screen, sir, but you will be able to see your title.
What do you see now?
Just you are just sharing your screen.
Yeah, my screen means okay. No, you could see my this title page of my presentation.
Yes, sir. We couldn't able to see. No, sir. Right now you can start your presentation, PPT. So since you,
Yeah, that's what
you
PPT I
see your,
projected it, but it is not coming.
Sir, can you kindly send your PPT to my WhatsApp number, sir?
Give me your Gmail ID.
Sir, Gmail ID is hodmet
1 minute.
at jpcue.ac.in.
Oh, you type it.
I will
Okay.
send you through WhatsApp also, sir.
No, WhatsApp is somewhat difficult right now. Okay, but Gmail I can do immediately.
Okay, sir. Okay. Okay, sir. I will send you a mail, sir.
Yeah, you send your Gmail ID to my WhatsApp first. Okay.
Okay, sir. I will send you through WhatsApp and mail, sir.
Yeah. Okay. But why I could not able to share? Yeah, man. How to work? Okay. Though I give a kind of sharing. visible?
Yes, sir. Yes, sir. Visible, sir.
My PPT. Please, you do that. Okay. No, this is not coming in.
Yes, sir. Just give 2 minutes, sir.
Yeah, sure.
We will present, sir.
Did you receive my item?
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Okay.
Could you see this now?
Yes, sir.
Yes, sir. Yes, sir.
What my presentation has come in?
Okay,
Yes,
sir.
sir. Advanced composite
Yeah,
materials.
very good, man. Yeah, okay. Then sorry. Okay, yeah. Now it has joined. Okay, yeah. Okay. Shall I continue now?
Okay.
Then?
Yes, sir. Yes, sir.
Audible?
Yes, sir. Audible, sir.
Okay, yeah, good. Okay, sorry for the interruption. Okay, there is some linking problem. Yeah, now it is okay, no?
Yeah, okay, sir. Okay, sir.
Okay, yeah, okay.
Go ahead, sir.
Thank you very much. Okay, sorry for the delay. So I thank, first of all, the founder of this TNI group of institution, okay, Dr. Arul Raj and Madam Hamlet, and our esteemed, distinguished principal of this campus, okay, Rajkumar, and the organizing committee members, Siddharthan and Palani and Jansi, and all other organizing committee faculty members. They have really toiled very long to make this third international conference as a successful one. Okay, I thank everybody for their hard work, and I'm sorry for the slight delay in the presentation. And I know that your college is doing very, very well, and I really congratulate all the faculty members and the students to get a few innovative projects. Really, I'm very proud about that. So using the minimal facility, you can do wonderfully well. So I thank all the people and all participants and dear students. So this is a kind of a presentation, a case study. I have selected 3 case study from our own doctoral work. So this is mainly on composite materials. So we have done a lot amount of work on both metal matrix composite and the polymer matrix composite. And you need not think very big on seeing the title advanced composite material. It is not a kind of very great sophisticated material, or they have been synthesized using sophisticated machines, or not like that. Using very simple techniques, only with some innovative idea, it is possible to make a kind of a composite with some specific advantages. That's what the idea behind this. So I'm going to present 3 case studies. All are from my students, doctoral students. They have almost completed all the degree, except the third one is a submitted thesis. So the 3 selective composites, it's appropriate to call this as a kind of special composites. We have many type of different dishes. You take your rice and you take sambar and other thing. But when you want to get a special dish, then you add some special ingredient. You make some sweets by adding some kind of sugar and other thing, so that you get a kind of the sweet flavor. So like that, this composites also can be synthesized with this adding some special gradients, and also you have to do some kind of engineering idea. Then you can get a kind of composite to suit a kind of particular need. So that's what the idea we say. Advanced composites, they have been tailored, or engineered to meet some kind of specific applications. So like that, now today I'm going to present. So possibly I will take another half an hour to 40 minutes. Time is short. So 3 doctoral research, so that you can also do, even a BE level student also can start doing this kind of one. You can synthesize a kind of composites with some engineering idea, to suit some kind of specific requirement. Fine. So today we are going to see 3 type of composites. Fly ash filled polymer matrix composites. So this is developed with a kind of targeted idea of making a kind of composite which can withstand even high temperature to the tune of say 150 degrees centigrade or so on, even for a longer durations. with adequate amount of a kind of resistance for moisture absorption, resistance for even some kind of impact, strength like that. So therefore the specific target is to meet some kind of improved thermal resistance. That's what the idea for the first one. And the second one is kind of stainless steel wire mesh reinforced polymer matrix composite. This is mainly the idea of making a component which can have kind of resistance for impact loading, sudden impact loading. A low velocity impact that is normally encountered in a kind of automotive body. You occasionally hit with here and there. So even in spite of that, yeah, could you hear me? Hello?
Yes, sir. But
Yeah.
the PPT is not open, sir.
PPT, oh man, so it is not moving, yeah?
Yeah.
Yeah. First, you can see that.
Sir, we see advanced composite materials, fly ash filled composite,
Yeah.
Pandira.
Yeah, that's yeah. So now we come the third slide.
No, sir. PPT is not.
The slides are not
open.
visible. We could not yet open the PPT.
Okay. But you are now reading this. That's what the PPT.
The title of the.
You could not able to see.
We just could see the folder window having these.
And what do you see now? Initially, you see no.
Sir, we see only the file name, sir.
Okay. But I have opened that, but it's not moving. Huh?
Yeah.
Yeah, but did you receive my presentation? I have sent it through Gmail.
Okay, sir. Okay, sir. Now we present the PPT, sir.
Sir,
Yeah,
our staff will open the PPT, sir.
Yeah, okay.
You can see and present, sir. He will change the slides, sir.
Yeah, exactly. That's what it's a better idea. Yeah.
Okay, sir. Thanks.
On opening, then you tell me. Okay, I will do that. Okay, accordingly.
Okay, sir. Sure, sir.
Sir, did you see the PPT, sir?
Yeah, I could see now.
Okay, sir.
Yeah, okay. So that is better now. Okay, go to the next slide then. Yeah, okay. So this is what now I'm telling about that. Okay. So these three cases now we are going to present. All the three are from my doctoral research. The next slide, please. Yeah, go to the next slide, please. Could you hear me? Next slide, please. Yeah, good. Okay, so this is on the fly ash filled polyester composite using ultrasonic cavitation method. This was done by Mr. Nandakumar, who is currently assistant professor in Department of Mechanical Engineering, Sairam. It is coordinated by another my colleague, Dr. Hariharan. Okay, the next slide, please. Yeah, okay. So this is only to say, okay, the composite material is nothing but a kind of macroscopic polyphase material. The meaning is it has two or more distinct materials, but they have a kind of sharp interface between them. That is the difference between a composite and a kind of an alloy. In alloy, it's a kind of atomistic mixing of various elements. For example, if you say a steel is a kind of an alloy where iron and carbon, they are in the atomistic level, they are getting mixed. Whereas moment we say a fiber reinforced plastic is a kind of macroscopic mixture where the resin and the fibers, they are now in the macroscopic, they have been mixed together. That's what the major difference. So a composite is a kind of a macroscopic mixture where a definite boundaries between the matrix and the other material. So we have many different kind of composites like a fiber or a kind of particle filled and so on. The one what we are going to see is a kind of a particle filled composite. Next slide, please. Next slide, please. Yeah, okay. So filled polymers, the meaning is here. So normally even to economize, to make a kind of a cost-effective polymer, they add some kind of minor ingredients which will occupy the space and then reduce the amount of the polymer. By doing so, you can reduce the cost. For example, even the kind of the plates what we're using for the dining plate called the melamine plate, it's an unbreakable plate. It's a kind of a polymer-based one, but where the kind of the gyoline, the clay, and the silica particles are being mixed together, and then they fuse it and then make the plate. So this plate having kind of some plasticity as well as a kind of standability for even temperature and resistance to moisture. So that's for a very simple applications. Whereas the moment you go for the kind of some high-end applications, then you have to go for selective additions of a kind of refractories with a kind of improving the thermal resistance and so on. So therefore, in that way, now in this project we have selected adding fly ash. Fly ash is nothing but the residue obtained from the thermal power plant. On burning the coal, you will get a kind of the residue ash. So there will be very fine particle. So they can be graded, and in optimum quantity that could be added to the kind of your polymer. By doing so, you can now increase the kind of the application temperature of the polymer. That's what the idea. Okay, next slide, please. So with that in our idea, so we have now gone for the kind of the FA, the fly ash filled polymer composites, but we cannot arbitrarily put fly ash. So you have to now go for selective additions in the selected quantity and the kind of selective size and so on. How now you are going to prepare them, all are critical. This is what say engineering the kind of your product. So it's a kind of engineered composites. So therefore you have to go for a detailed study to know about what could be the suitable size of the FA particles, what should be kind of the percentage or amount of the particle we can put, and also we cannot simply put them and we cannot disperse them. So it's not going to undergo a kind of dissolution. It's not like kind of putting a salt into the kind of a sambar where it will undergo dissolution. These are the particle, they are going to stay. So therefore, if you put a particle, if it is high density, it will go and then settle down. If it's low density, it will float up. So therefore, you have to go for a kind of some method by which it will be uniformly distributed. So for that, we use a technique called sonification time. So this is what is shown there, sonification time, how much we should give ultrasonic vibration so that we can uniformly disperse the particle. So once doing that, then we have to verify the kind of property like mechanical, thermal, and dynamic properties of the combustion. This was the idea. So we are accordingly gone for that. Okay, next slide, please. So therefore, the objective of the item is to synthesize, to make a kind of an innovative composite with the selective additions of a fine particle, what we say, even submicron size or nearing nano size. So a kind of nano composite, nano-sized particles with a suitable kind of, you cannot obtain as such from our source, that you have to go for kind of particle disintegration, comminution, what do you say? You have to reduce the size, and then you have to sieve them and then get the selective grade, and then you have to now add them to the kind of your resin, and you will go for the testing. So here we have tested the kind of normal test like flexural strength, hardness, and also since it is going to be used in the kind of engine covering, it's your automobile engine covering, so it should be able to withstand even kind of vibration. It should resist the kind of water absorption. So all these items also we have studied. So that's what the purpose is now, to prepare or the kind of obtain a kind of a suitable composite which can withstand high temperature, should absorb the vibrations, resist the kind of water absorption. This is what our targeted idea. With that, this composite is being made. Next slide, please. So this is a methodology. Okay, so we have selected a kind of the application. What we have item is mainly for automotive engine. Okay, covering. This could be used for any other purpose also. So with this idea, normally metallic metals are being used. So they are high in weight, and also they will not absorb the vibration. Therefore, the vehicle will always vibrate. Whereas this, by doing so, it is possible to now go a noise-free, a kind of vibration-free, travel. At the same time, lightweight, like this was the idea. So we selected the kind of matrix as a kind of unsaturated polyester resin, and the submicron size fly ash particles, and these are being synthesized by adding ultrasonic sonification, and then we have studied a kind of microstructural analysis, hardness, structural strength, and moisture absorption, and so on. Okay, this is what the way by which it has been done. Okay, the next slide, please. Okay, so the matrix what we studied is a kind of polyester resin, and we prepare the kind of fly ash particle. The normally ash received fly ash particle from our thermal power plant is coarse in size and also having many different kind of impurities, other things. So you have to grade them, and then you have to now size them to the kind of record way. So that we obtained by doing high-speed ball milling at different durations to identify what kind of size we are getting. Then the particle size were analyzed using a particle size analyzer. So from our analysis, what we could be able to obtain is we selected 3 different sizes of the FA particle ranging from 900 nanometer to 700 nanometer, and we checked the kind of what is the role of this particle size, and also we have selected 3 different weight percentage additions, 2, 3, 4. So these are items based on our previous literature review. You have to identify some range, and then from which then you can go for further fine tuning. What is the much more suitable one? So that's what the study purpose. So the broad range has been obtained from literatures, from which we found that anything more than 5% is not suitable, and similarly anything less than 1% also will not give you the expected property. Therefore, accordingly, we have selected say 3 ranges, 2, 3, 4, and this particle size also still further we can go, but our limitation is we could not go below a kind of say some 500 nanometer or something. The type of machines what we have could not be able to give very low particle size. So accordingly, now we have selected the particle size and the particle percentage. Accordingly, it has been made. Next slide, please. Okay, so once we obtain this, then for our subsequent presentation, we have made a kind of a code to describe that. We have made 3 different weight percentages, 3 sizes. So accordingly, all the compounds are now given a kind of this notation. The last line you can see that 3FA8S. The meaning is 3 weight percent fly ash added and 800 size nanometer. If it is a 2FA, say 7S means it is 2% fly ash added and say 700 nanometers. Like that, now we give some designation for the composites. So then totally we made 9 different varieties of composites, and then checked the property and finally identified, zeroed down. This is the best one for our requirement. That's what the idea. Okay, next please. Yeah, okay. So therefore, once it is being now the broad outline has been made. What are the kind of tests we have done? That is been listed there. So we measured the particle size, based on the kind of your ball milling hour. We analyze the microstructure, how our particle is distributed in the given matrix. We checked the fluxural strength, hardness, water absorption at low temperature and also at high temperature. And we went for thermogrametric analysis. That's what mainly the one, thermogrametric analysis. It tells about the kind of degradation of the polymer at elevated temperatures. So it heat your polymer and then check, when it is going to be degraded and then how, the degradation is going on. So all this item we can do. Then the final one, what is shown is dynamic mechanical analysis. This is a kind of to testing a viscoelastic material. So where the stress strain will not match together. In a metallic material, moment you apply stress, immediate strain will be onsetting. But whereas in the case of viscoelastic material like a polymer, there will be a lagging between the strain onset on application of stress. This lag only now gives a provision for your damping capacity. So therefore, by using dynamechanical analysis, we are going to evaluate the damping behavior of the. So these are the last the 3 tests are very important for our application point of view. Next slide, please. So this tells our preparation method. So we obtained the kind of our our fly ash from kind of Neyveli NLC plant. Okay, and then that is being the sieve set. It's a kind of sieve set means nothing but what our mummy is using for sieving your rava or the kind of wheat atta like this. Okay, but here we have a series of sieve sets. So large opening from the very small opening at the bottom. So in this t-shirt, the top in the put the players and then now shake them using our suitable sieve shaker, and it will greater that. So we took the final very fine particle and then you took it for further combination. Okay, so that from the sieve analysis we removed all the coarse particle, took only the fine particle, and still further we have gone further because in this what we could able to find is the particle sizes of the order of say ranging from 100 micron to say 50 micron and so on, but we want in nanometer size. Therefore you have to go for further reduction in the size by using ball milling. Next slide please. Yeah, so this is what the kind of ball mill. So we took this a small stainless steel chamber with thick walled one. Inside you put the kind of your fly ash particle. The second picture shows a kind of machine in which you put them, and then it will be gyrated, rotated at a very high speed. Then the particle size will get undergo reduction. The third picture shows a kind of particle size analyzer where you can now check what is the kind of distribution of various particle size and like that. Okay, yeah, next slide please. So once this particle size are graded and we obtained say 2, 3, 4 and say 700, 800 nanometers. So then we prepared 9 varieties of kind of your polymer composite. So how to mix them? So to mix them, the picture shows this is a kind of even the bottom you have a kind of furnace, even you can do at high temperature, but we did it at room temperature. So in the place you place your say a kind of a crucible where you add the resin and then put the particle. Moment you put the particle, it will only float up the fine particle. So you have to slightly stir them. Then you have to insert the top ram inside, which is ultrasonic, which will agitate at a kind of high frequency. Then the fly ash will get uniformly distributed. This is the idea for the kind of ultrasonic cavitation by which you can ensure fine particle can be uniformly distributed in the resin. So this setup shows that. Next slide, please. So once we did the kind of one, this is done in the kind of almost a liquid state or something, some viscous liquid like your castor oil, something, or a honey. Okay, so it will be condition of kind of like a honey. Okay, where you put the kind of particle and then you stir them together. Okay, normally if you get sick, your mom used to do take a honey and then put a kind of pepper powder and then she mixed them and then she give to you. So the same way we put the kind of resin, put the kind of your fly ash particle, but for you mixing we use the ultrasonic vibrations. So once it is ready, then the top picture shows a kind of mold in which the mixed resin is poured, and then you get a kind of sheet-like thing, thick sheet, like in a cardboard. Then it should be cut. So cutting should not be done by your hacksaw because it will give the kind of edges will be broken. The moment the edge is broken, then subsequent tests like flexural strength or the kind of tensile strength, the results will not be good. So therefore, go for cutting. This bottom picture. By using abrasive water jet, then we obtain the strip specimen, which is shown there. The white color specimens are the without adding the fly ash, and then the almost gray color or black colors are with the added fly ash. Okay, so this we cut the kind of strips, then we took it for the further testing. Okay, next slide, please. So we tested, first microstructural analysis. How the fly ash has been now distributed. So therefore, now we get a small pieces pointed tip. Because the metal will be homogeneous everywhere, therefore anywhere you can put the indent. Moment you go for a heterogeneous material, like a cardboard, like a honeycomb structure, where you have to put the kind of indent over a larger area. Therefore, you have to select an indenter which is a kind of larger area, like a ball indenter. Then you have to do the test. So accordingly, for polymer testing, went for RL, that is Rockwell RL scale, and test is conducted. And the bottom picture shows the kind of testing at the kind of water absorption, normal temperature, and as well as in the kind of accelerated hydrocarbon, so in elevated temperature. And also we also thought about this, not only on the kind of pure water, suppose in the kind of sea coast regions, you get a kind of even the moisture will be containing salt particle. Therefore we conducted the kind of our this hygrothermal test. That is even at a boiling water, how much amount of water is being absorbed. Even room temperature, how much amount of water is absorbed. So that water is salty, by taking a real water from the sea itself. So this the hygrothermal test is conducted in the bottom setup. Next slide, please. Yeah, so This is to check about the kind of your thermal degradation. So the top picture shows the kind of thermogravimetry, okay, analyzer. So this is thermogravimetry means nothing. Gravity means it's a kind of weight. So what you say, as you increase the temperature, how the mass is going to deteriorate. Okay, just start, okay, undergo degradation. Degradation means okay, start okay, burning, you can say. So it undergoes a kind of loss in weight. So thermogravity study means this is normally done to analyze over a temperature, okay, how the material is going to lose its weight. So that is being done at some selective heating rate, 10 degree per minute. And we went from even 160 degree from room temperature only, but from okay 160 to 1000 degrees is a critical range. When at the time okay it started degrading, so where we carefully observed okay how it is going to take it. And the bottom picture shows thermomechanical analysis, where okay, you have to know this also done at room temperature, elevated temperature, to know about the kind of the lag between stress and strain, which gives an idea about the kind of damping behavior. So damping behavior is tested in the kind of your dynamic mechanical analysis. These are the two important tests we have performed. Okay, next slide, please. Yeah, next slide. To go for results and discussion. Yeah. So this is okay. The raw fly ash. Okay, if you see the center line, okay, now which has a kind of larger percentage in the bottom. See, this is around 100 okay micron. This size in this micron size versus okay percentage. So the ash received one is as a kind of okay mean value of around 100 micron, but having even some okay 500 micron something. 500 micron is 0.5 millimeter. Some are larger particles. So there are some submicron particles also available, but they're very low in amount. So therefore, this as could not be used for our purpose, because this will not improve okay, our mechanical properties. It will deteriorate the mechanical property. This kind of coarse particle addition. We have to go for minimizing the kind of size. So we went for ball milling. Okay, next slide, please. So on ball milling, and then by analyzing in our particle analyzer, this is after 10 hours of ball milling, we could see that we get around 900 nanometer. This is 1000 nanometer means okay, almost 1 micron. So we get around 0.9 okay, micron on 10 hours milling. Okay, then on doubling the kind of milling hours. Next slide, please. So we could now decrease only little bit further. Okay, you can see the peak one, say 800 nanometer. Okay, so on 20 hours we get the kind of 800 nanometer. Next slide, please. On increasing the ball milling hour further, okay, to around 45 hours. So we could able to achieve almost nearing 700 micron. Next slide, please. Yeah, okay. So this is 45 hours. We got around 724 micron. See the first line, peak one, 724 nanometer. Okay, so therefore, so this is the one. Then we double the kind of okay. Once 100 hours, so it's not giving much amount of results. Therefore, what is the maximum okay fineness? What we have to do is 700 nanometer. Okay, it's a kind of 0.7 okay micron, submicron levels. Next slide, please. So therefore, for our studies, we have okay selected the kind of these three okay the 2, 3, 4 serial number called 900, 800, and 700 nanometers size okay particles that we have now used for our further study. Okay, yeah, next slide, please. So using this, we have prepared the kind of our one. Okay, so this some analysis showed the kind of okay even some amount of larger particles, okay, 5 micron, but you can see the background, there are no small particles. They are kind of submicron particles. Okay, so by grading, we remove the kind of okay, large size and we use only the small size okay, particles for our preparation of the composites. Okay, next slide, please. Yeah, okay, so this is our microstructural study. If you see the pure resins, okay, we could not be able to see any kind of features. But moment you go to the 2% FA filtration, you can see the white dots. Okay, now these are the our fine fly ash particles. Those say white dots. Okay, that will be some amount of okay agglomeration will be there. We will agglomerate in this. Our intention or our objectives are coming down. The meaning is they get agglomerate and the property will come down. So therefore, moment you go for okay 3%, you can see at some place we get a rounded structure. That is agglomeration of the particle gas. Moment you go for 4%, again you can see at many places okay the agglomeration happens. So therefore, what we felt is okay 2% is the kind of our better okay good dispersion. 3% is okay. But moment you go for 4%, then the dispersion is not uniform. The particles get okay joining together and become agglomerate. So this was some kind of an idea. Therefore, either 2 or 3 will be good okay for a kind of better distributions. Okay, next slide, please. So therefore, from this okay, you can now say that okay this is 2 or 3% is distribution wise that is a better one. 4% distribution wise okay not good. Okay, that is in the microstructural point of view. Okay, yeah. Next slide, please. Yeah, so then we went for the kind of 4-point bend test. So detection for the flexural strength. So you can see that the top line 0% if it means pure resin. It has a value of very less 17 MPa megapascal. But if you add only little amount of 2%, so strangely the strength comes down. So the reason being which may introduce some amount of void, or which may initiate the crack at the sooner that for the failure occurs. But for the 3%, you can see the increase in the strength. Moment again, if you increase further 4%, again it decreases. So overall, if you see, the additional 3% gives the kind of the better value. So therefore, and also on adding fine particle, the last column say FA7S. Where the 700 nanometer size particle, all items almost gives more than your base resin, except the fourth one. But all the 2 and then 4% shows the increase one. But out of which this one, the 3% fly ash additions at the 700 nanometer gives the kind of the high value. So therefore, that is the best one for in the strength point of view. So the strength point of view, a kind of 3-8% with the 700 nanometer gives a kind of almost 70% increase in this strength. This is what major observation. Next slide, please. Yeah, so this the diagram shows us stress strain behavior. The plain resin, it increases and then occurs a kind of some sudden failure in the our final stages. Reaching the peak value. What is the ultimate tensile strength? Here it is ultimate flexural strength. Yeah, next slide, please. So moment you go for the composite, you can see many serrations. So therefore, the particles also participate in the load distribution. So therefore, the failure occurs again, but another particle offers resistance. Therefore, the load buildup. There is a fracture again, a kind of a particle resin interface. Load falls, but again another particle rises its resistance to the load. So like that, many serrations, the drop and pickup. This is what we call the second serrations. This clearly shows that our particle participate in the load sharing. So that is being shown there, and finally that goes again a peak value and then failure occurs. So this the pattern one can analyze and get idea about how the the load sharing is done by the particles. Next slide, please. This for 2%. So next one is for 3-8%. Here also you can see the double peak configurations. The final stages, the final particles, it increases one. Next slide, please. The 700 rays, which shows a kind of very high peak value. Though there is a relation also there. So this tells about the kind of what is the strength relationship, how the particles participate in load sharing. Next slide, please. So therefore, from this flexural strength of point of view, if you see the one which a kind of 3-8% and also 700 nanometer, that gives a kind of the very high flexural strength. So beyond which if you add again, the strength comes down. So this is one of the major conclusions what you can write. Next slide, please. So on checking the hardness, hardness almost it goes only uniform, whereas we can see in the kind of flexural there is a kind of inversion. 2 low, 3 high, again 4 is low. So therefore one can say, yes, 3 is my optimal value. But the hardness, if you consider, as you increase the kind of the percentage of fly ash, hardness continue to increase. Therefore, from the hardness point of view, you can see the last column, see the kind of the 4-8% added, even 700 nanometer. Particle fineness means hardness is more. That is again a good observations. So which gives a kind of high hardness value. Whereas the percentage is low means it is adequate. But hardness, if alone the criteria, then one can say you can go for the 4% one. But strength point of it comes down. That point should be no. Next slide, please. Yeah, so this hardness on comparison, you say 2 and 3 is almost comparable. That's what but 4 is somewhat high. But however, strength wise, the third is a better one. Next slide, please. We went for the kind of water absorption. So water absorption, if you see pure resin is good because which will not absorb any kind of water. It is almost surface tightly sealed. So therefore we could not able to see any kind of water absorption in the kind of pure resins. But moment you add the kind of particles, there will be a kind of small void between particle and the kind of resin, therefore through which the moisture gets entrapped and then which increases. But you have to go for whether it's acceptable or not. So on checking that, the 2% gives a kind of around 0.8% change in weight, whereas 4% gives around 2% change in the weight. So therefore, the around 1 to 1.5 is the kind of 3%. So therefore, we say we can permit up to say some 2% or something. Then we can say, okay, the better is either go for 2% or 3%. Moment you go for 4%, then the water absorption is more. Okay, that is also not a good one. Next slide, please. Okay, so this shows, so even the initial time, okay, the water pickup is not high, but the later period, so at the time only the gap also somewhat widened, okay, because of soaking of the particle, then okay, the water enters in more, therefore the water absorption increases. Okay, yeah, next slide, please. Whatever it is, okay, 1% to 2% is okay. So that is the thing, okay. So therefore, around 700 nanometer size is somewhat okay, which gives a kind of minimal water absorption. Then we wanted to check at a high temperature. Therefore, we say even at a temperature around 60 to 70 degrees, that's what normally encountered in the kind of the bonnet of the your automobile. So we heated up the kind of seawater and put them and checked for the kind of water absorption at the high temperature. What is the accelerated the hydrothermal test? Next slide, please. So here also one can see that when moment you go for the accelerated one, even the pure resin starts showing some kind of fissuring, and then the moisture absorption takes place. Whereas the increase in the kind of water absorption is only marginal in the case of our 2 to 3. Whereas 4% it goes even beyond 3, but whereas around 2 to 2.5, these 2 and 3 weight% fly ash is stabilized. Okay, is okay. 2% water absorption is okay, because pure resin is also going to have around 1.5% of moisture absorption after prolonged exposure. So therefore, from accelerated hydrothermal test, we can say our composite 2 to 3% is suitable for even applications. Next slide, please. Yeah, so this is the most important one. Okay, what is a thermogravimetry study? That is on heating our polymer, how it is going to start. Okay, so this the line, okay, which a line with the peak shows a kind of differential, whereas a line on the top, okay, the kind of continuous one, okay, which is a kind of one which shows the kind of the change in the mass. So from which you can identify, okay, from the x-axis at what temperature the degradation starts, at what temperature the peak degradation, at what temperature degradation is completed. So from this graph, okay, you can obtain the kind of a complete picture on, so degradation, what is the starting temperature. For example, in the plain resin, it started at 280 degrees. See the bottom script. So 280 degrees, it should be degrees centigrade. And peak degradation occurs at 384, and almost at 450 degrees centigrade, completely it is deintegrated. This is degraded. So that, okay, you can get a complete history about the thermal history, okay, how the degradation starts and then progresses. Okay, so this one for the next slide, please. Next slide, please. For 2%, you can see that, okay, the degradation start at 320, okay, so that, okay, 280 for our plain resin, 320 for the 2% one. Peak degradation at 395, and almost, okay, 430, this degradation is getting completed. Next slide, please. 4%. Okay, so this data started 348, okay, peak at 410, and like this. Okay, yeah, okay, 4% of like this. So now go for the next slide, okay, where it summarizes all the findings. Yeah, so from which you can see that, okay, the degradation temperature, start temperature is now increasing, okay, almost around 28 to 30%, and even the peak degradation also now, okay, increase to high value. So therefore, from which you can say around 28%, okay, increase in the degradation start temperature is there in the kind of 3% fly ash. Okay, this is a kind of a good observation. Yeah, next slide, please. Okay, so therefore, you can say a kind of the fly ash or composite, there is a 30% improvement in the kind of degradation temperature. That is, okay, good for this. Okay, and in particular, even 3% of particles, okay, gives kind of a better, okay, thermal stability. Next slide, please. Yeah, okay, this is what, okay, our dynamic mechanical analysis, which analyzes the kind of, okay, on vibrations, okay, and also at high temperatures, how the vibration can be alternated. That is being checked by checking the kind of difference between the stress and then strain onset. Okay, so that is being done, okay, using our dynamic mechanical analysis. Next slide, please. So the results, okay, indicate that, so as you now increase the amount of fly ash content, see the kind of the first one, the maximum damping value 0.38, 0.42, 0.43, and 0.47, and so on. Okay, so therefore this shows that, okay, the damping value is increasing as you know, increase the kind of your 1 and it goes to kind of around nearing around 0.5. That is a good value for getting the kind of a good damping behavior. Okay, so therefore the fly ash additions improve the thermal stability and also improve the damping capacity. That's what the kind of our final finding. Next slide, please. Next slide. Yeah, okay. So from this work, you can say there is about a kind of 20% improvement in the kind of a damping capacity is identified on adding the fly ash. Okay, next slide, please. Yeah, okay. So this, if you know, again, check that, okay, this changes with respect to temperature. Even if we go for high temperature, how the damping behavior changes, again, we could be able to notice the inversion. Therefore, the better damping is observed in the kind of 3% fly ash at all temperatures. Even at a high temperature, it's also better damping. So therefore, by all this one, by strength wise, by damping wise, and also minimal water absorption and the kind of high temperature stability always, then we felt this 3% FA with the kind of 700 nanometer gives the kind of optimal property. Next slide, please. Yeah, okay. So next slide. Okay, so this was the study. Okay, so 2, 3, 4% and 700 nanometer combustion has been prepared and studied. Okay, next slide, please. Okay, so microstructure wise, 2%, 3% are better, 4% is not uniformly distributed. Flexible strength wise, okay, 3% gives a kind of high value. Harness wise, 4% gives a kind of the better value. Water absorptions, okay, 2 and then, okay, no, 3% okay, 4% absorbs more one, that is not suitable. Next slide, please. Okay, so the accelerated test also proved that, okay, no, 4% is, okay, absorbing more amount of moisture. And thermogravity showed that, okay, no, we can now increase the kind of thermal stability by to the order of, okay, even 40% and so on. And dynamic damping behavior also we observed, okay, to get a kind of, okay, no, a high damping in the one. So that finally the 3% fly ash with 700 nanometer order composite can be considered as a good combination of the properties and could be selected for the automotive engineering, okay, cooling applications. Okay, so this is the one of the one, and accordingly this is supported by our Ford motors. Okay, they also wanted to go for indigenization and also going for polymer combustion like this. Okay, so we made some kind of, okay, no, presentations. A few papers are, published in, okay, no, the Scoopers and then Web of Science indexed one, and even at one place, okay, no, because of the application oriented we got the award. Okay, fine. Okay, yeah. So this is the one. Okay, now, okay, time has gone. Okay, sorry for the delay. Okay, yeah, okay, so I'll go for some nutshell presentation for the other one. Okay, so that without eating the times of others. Okay, yeah. Next slide, please. Next slide. Yeah, okay, so next is on a kind of this combustion. Okay, you show the title first. Okay, no, you go title again. Yeah, previous one. Yeah, okay, so this is the one, okay, which shows about, yeah, next slide, please. No, yeah, no, previous, don't run the previous. Yeah, okay, keep it there. Okay, yeah. So this is on a kind of, okay, preparing a combustion, hybrid combustion. Hybrid means, okay, no, by adding 2 or, okay, more number of, okay, your reinforcement. Okay, so in this case, in addition to the kind of glass fiber sometimes, like, breaks and which will not have the adequate impact. So we thought we can have a kind of, okay, a metal mesh also, very fine mesh. You cannot put a coarse mesh which will be counterproductive, which will not get a bonding with the kind of one. So therefore we put a kind of a very fine mesh, SS mesh in the middle layer. We made a kind of multi-layered composite. We checked for the kind of the low velocity impact behavior. So this was the idea. Okay, yeah. Now you can run through. You go. Okay, go fast, right? So yeah, go. Yeah. Next slide. Next slide. This sort of hybriding I told that. Okay, so need for wait. Okay, so here, okay, now you can hold it now. Okay, yeah. So need for the studies, as I told, okay, we have to now go for the kind of some selective preparation of combustion with a kind of high, okay, now your impact resistance. So this was the idea by which it has been now prepared. Next slide, please. Next. Yeah, next. Go for, okay, no. Yeah, next also we can go next. And next. So we made a kind of some surface treatment in order to improve the bonding. Okay, that's what the idea. So you have to give some surface treatment. Already the glass fiber comes with a kind of silane coating, but instead we checked whether go to very mild acid or a mild base. Okay, no, it's a very fine filament. So should not affect them. Okay, otherwise which will be again deleterious. So to go for careful surface treatment with the mild reagents. And similarly, we did some surface treatment for the stainless steel mess, and by doing so, we can improve the adhesion between the resin and our item. That's what the idea. Okay, next slide, please. Yeah, so this is what the way in which I prepared. Okay, no. So we placed our these are the woven. Okay, no, this glass fiber cloths. Okay, so they are being now put as a kind of 3 layers. Middle layer is a kind of stainless steel mesh, and then we went for another 3 more layer of the glass fiber woven cloth. Next slide, please. Okay, so this is what the sono. This kind of 7 layered one. Okay, the middle layer is now we altered them. Okay, like a kind of one with a kind of stainless steel mesh like that. Okay, so fine. Okay, next slide, please. So 6 layers of your glass fiber, and then the middle layer is a kind of one. So we made almost 8 different varieties of the composites. 3 non-hybrid. Okay, only untreated fiber, and then acid, and then base treated fiber. And then 5 different varieties of with the stainless steel wire mesh, okay, with a different kind of surface treatment, like that. Okay, so this all the 8 items are tested. Next slide, please. So we have done mechanical testing, tensile test, structural test, interlaminar shear test, impact test, and low velocity impact test. Okay, a simple ISO, and also low velocity can drop height test. Okay, hammer will fall on your laminate, then we test. So all the tests we have performed. Next slide, please. So again, all the specimens should be cut by abrasive water jet. Otherwise, if you cut by your hacksaw, then which will not give a good value. So this is one of the point to be noted. Next slide, please. Okay, so results, I will show that. Okay, since time is unavailable, 5 minutes. Okay, yeah, next slide goes. Next slide. Next slide. Yeah, so it's a kind of some picture to show that. Yeah, hold it. Okay. So on treatment, you get a kind of some micro pits. Okay. So this micro pits facilitate the bonding. Okay. So the idea for giving surface treatment for the glass fiber. Next slide, please. For the stainless steel, again, we went for electrodissolution by also micro pits can be produced. Our next slides. By doing sand blasting, using a kind of fine sand, blasted over the stainless steel, we can get a small pit. Okay, these pits will improve the adhesion. Okay, so once you do the surface treatment, then we made our composites. Next slide, please. Next slide. Okay, so we tested the kind of tensile strength. Okay, next slide. We tested for the flexural strength. Okay, interlaminar shear strength. Next slide. Impact, test. Okay, so next slide. So you are being conducted many different kind of test, mathematics, English, then physics, chemistry, and so on. Finally, you put a kind of rank. How to put? You sum it, all the item, we make it some difference ranking, and then from which is the best student. Okay, so like that since we have 4 or 5 tests. So from this, we took a kind of some parameter by weighted average method. We found out which gives a kind of optimal combination of property. Like you are being ranked, though you studied many different subjects. The same way we use a kind of concept called weighted average method called strength factor, and using which we found which is the best one. Next slide, please. So the last column is strength factor. So from which if you see 93 mark, okay, this guy, number 7th guy, this kind of acid treated glass fiber with electrodissolution mesh, which scored 93 mark. The next comes a kind of another one, acid treated glass fiber with a sandblasted mesh, 92 mark. So then we told, these 2 guys, they have scored well. And the bottom is around 62 mark. Okay, it's a kind of untreated glass fiber one. Okay, so like that, you can combine them. Though we have many parameters, by using weighted average, we could now single out who is using optimal combination, who is a rank 1. Okay, like that. Okay, next slide, please. So to quickly run through, low velocity impact. So by dropping a kind of hammer, then we can check them how damage occurs. So this loop, you say displacement goes up to some maximum and then return them. So return means all is elastic collision, no damage at all. These are 3 meters per second. But the moment you go for higher kind of impact velocity, next slide goes. Next slide. Next slide. at 5 meters a second, if you see some of them get perforated, okay, they will not be returned. Okay, no, that's what the picture shows. No, a kind of elliptical picture shows it has some kind of, okay, no retention, elasticity, no damage. Okay, whereas a kind of open one shows kind of damage is more. Okay, like that you can get an analysis. Next slide, please. Next slide, next slide. Next slide. Next slide. So close curve, no, yeah, next slide. Okay, this will skip it. Okay, next slide. Next slide. Next slide. So from the energy absorption point of view, okay, you can say, okay, which gives a kind of the better one, but in show that directly to fractography. Next slide, you go next slide. So we did a kind of no analysis and found that, okay, a kind of the glass fiber and the sand mesh, okay, particularly the signless image with a kind of some surface treatment gives a kind of better value. Next slide, go to next slide. So all the, okay, 8 atom, okay, right from the right hand side is a kind of the untreated one, to the left hand side a kind of superior one. You can see this, okay, even the without the metal mesh, it gets even perforated, as you can see the hole. But see the left, okay, all the 3 specimens which are the sinus mesh, which gives a kind of the better, okay, no resistance for the impacting. So top side, and as well as you see the bottom side also. Next slide. Now, okay, so among this, okay, these are the item, okay. The perforated ones are the untreated ones, whereas unperforation is a kind of one, the treated and the sinus mesh one. Okay, next slide, please. Yeah, okay, so from which we can say that, okay, the treatment, okay, particularly base treated one, and as well as a kind of your electrode solution gives a kind of better combination of the property. No high impact strength also there. Okay, yeah, next slide, please. We'll skip it. Okay, yeah, go next. Okay, yeah. Skip it. Okay, this also we get at one. So this is on quickly, only 5 minutes. Okay, so therefore from the previous one, what you say, by using a very fine mesh, okay, you see, okay, it's kind of coarse means useless. Very fine mesh with the surface treated one in the middle layer, we build, okay, top and bottom layers with the kind of, okay, again a selective glass fiber one, or you can even place your mesh at some suitable locations where now you want to do the fashioning. Exactly, now your Bharat Benz, okay, no automotive, okay, the vehicle manufacturer, they use this because they make the bumper, okay, out of, okay, glass fiber one. But while fashioning them, okay, no, in the, if you put one bolt there, then the bolt region gets breaks. Then we told, okay, place a patch, a kind of a sinus mesh inside, then you can get a kind of better, okay, no fabrication capability. One. And other one is kind of, you can entirely make the bumper using the one. So it is being under consideration. But as on now, the Bharat Benz vehicle, okay, the lorry, you can see that, okay, the front bumper in the bolted region, as SS wire mesh is impregnated inside, okay, so that which will not give the kind of facility the one. Okay, fine. Other one now, okay, final one, okay, only 5 more minutes. Okay, I do not want to take much of time. So this is sandwich structure. Sandwich is lightweight structures, okay, used in the aircraft wings. Okay, so where it will appear to a kind of a larger one. Okay, yeah, next slide, please. Go. Next slide, please. Yeah, this one, hold it. Okay, so this is a sandwich structure. You can see the kind of honeycomb core, hollow core inside. Top and bottoms are the facing seat. Okay, so it will appear a very thick one, but it's very lightweight. But it should be able to withstand the kind of, okay, any impact loading something. Or aircraft wings are being made by using this kind of hollow structures. Honeycomb sandwich structure that is being called. Okay, but here, okay, no, that is aluminum honeycomb structure. The technology has been now developed, okay, with a greater, okay, no, say precision and something. But whereas we want to make such a structures for the resin-based one. But when you go for resin-based one, the honeycomb structure, okay, will not bond, okay, excellently well with the kind of your facing seat because there's a kind of only line contact. So we want to go for a different kind of configuration. Yeah, next slide, please. So the inner core can be of different type of configuration. Next slide, please. Yeah, okay, hold it. Okay, yeah. So the inner core can be even you put a foam, or you can put a kind of, okay, not like a truss members, or it can be a corrugated one. So we almost, okay, modified a concept of like a kind of a truss type of, okay, one, but it's not a kind of only a truss like a kind of your bar or the kind of beam. So instead we went for a kind of a novel idea. Next slide, please. So on replacing the honeycomb, okay, so these are the application. What you say, okay, this aircraft fuselage is very boost. Nowadays, people want to go for even, okay, this you can see your cardboard box, okay, packing cardboard, you can see it like this, okay. And this kind of structure can be made even for the partition wall for the kind of sky-raised buildings, okay, where it will not participate in the load sharing, only some partition application. Now, right now, people do with the kind of aluminum frames or the kind of plywood, but that can be replaced by the kind of our, okay, no, our idea is like that, okay, partition walls and also packing materials, okay, like that. Okay, yeah, next slide, please. The next slide. Okay, so the problem is difficulty in manufacturing like this. We went for the kind of innovative type of the inner core. Next slide, please. Next slide. Next slide. So methodology, what do you suggest? Next slide. Yeah, hold it. Okay, so therefore we made the hold it. Okay, this is what actually we made. So we made a kind of spherical. Code one. Okay, this is a kind of hemispherical, two hemisphericals, and they are bonded together. The top surface is flattened so that improve the bonding. So we made this our fabricated one. So the regular model, we put inverted type of core. We put a kind of staggered arrangement, and we interlocked. So 4 different type of the spherical core structures have been fabricated and tested for the various conditions. Okay, yeah. So this is what our idea by which sandwich structures are being made. Okay, next slide, please. Next slide. I will quickly run. Next slide. So various tests we have performed. Okay, flexural test, compression, and also the drop height test. Okay, next slide. Okay, so compression test, we made the kind of one and put in a UTM and just compressed down. Okay, next slide. Okay, so among which gives a kind of better one. So we made 4 different varieties. Okay, as I told you, say regular, inverted, interlocked, like that. Okay, so the various pitching distance, and we identified the interlocked one gives a kind of higher, compression. Next slide, please. Next slide. Okay, we'll go quickly. Okay, this shows a kind of the fracture pattern, how the kind of fracture occurs. Okay, crushing of the spear. Okay, and sometimes even interlaminar failure will also be shown. Okay, next slide, please. So this is under compression. So we compare with the kind of other published literature, and we say we have the kind of a better one like this. Okay, yeah. Next slide, please. Okay, flexural. Okay, no, you do flexural test, but you have to go for 4-point bend test. Okay, like that. Okay, next slide, please. Next slide. Okay, using single point and as well as even 4-point test. Okay, we conducted 3 different configurations, take the average value, and we gave some suggestion. Next slide, please. Next slide. This is kind of the flexural test. Okay, single point. Okay, flexural test. This is 4-point. Okay, 2 support points and the 2 point. Okay, the bottom was a 4-point flexural test. Next slide, please. So we using some suitable formulas, we arrived at the kind of flexural stiffness and some of the parameters and so on. Okay, next slide, please. Next slide. Okay, go quickly. Next slide. Okay, we don't want to discuss this. Okay, next slide. So out of which you could able out, which one gives a kind of better one. Okay, yeah. Okay, yeah. So hold it. Okay, so flexural strength interlocked one gives a kind of better fun. So 3 different cases we took it there. Okay, and then the interlocked IL mean interlocked had to give a kind of the high flexural stiffness. Next slide, please. Next slide. Okay, so we differentiated many different kind of way. By all the items shows that interlocked 32 model gives kind of better value. Next slide. Next, yeah, hold it. Okay, so this shows a kind of during flexural. How are the various type of flexural? Okay, during test, debonding, core crushing. Okay, these are the various failure type which occurs. That also we noticed. Okay, next slide, please. Next slide. Next slide. Okay, so next slide. This is a low velocity impact as I told. This is one of the important tests. So the specimen is fitted in the specimen, and from a height, impact will be falling on the kind of subject, and we used to know how the impact energy being absorbed. Okay, next slide. So the impact test is one of the interesting tests. Okay, from which we can understand how the fracture progresses. Next slide. Yeah, okay, hold it. Okay, so therefore here you can see, in the force time plot, you can see multiple peaks. Each peak correspond to one type of fracture. TMC means top matrix cracking, top fiber breakage, top perforation, upper portion of the core crushing, bottom portion of the lower portion of the core. So like that, this is what we say signature analysis. Each peak can be associated with one kind of particular kind of failure, and all the failure will not occur in all conditions. So which one kind of shows minimal amount of fracture, but same should absorb the energy. That's what the idea. Okay, so by which the impact items. So next slide. Next slide. Yeah, okay, so from which we found many different kind of analysis. Okay, so this is a kind of detailed analysis. Okay, doctoral work. I'm not going for all the detail. You skip it. Okay, go to the almost near end. Okay, skip it. Go. Yeah. So these are energy analysis. Okay, these are the various. Okay, hold it. Okay, yeah. So from which we can now know what is the kind of damage progression. Okay, so what are some of the tester specimens? You see the white region. Like say the fiber breakage, and then the matrix breakage is there. Okay, next slide, please. Next slide. Okay, so this analysis has been done by our even ultrasonics, by which you can get an idea about say acoustic emission technique by which the damage can be analyzed. Next slide. Next. Okay, next. Okay, yeah. So from which what we could be able to see this, there should be a kind of optimal combination of the strength as well as capability to absorb the energy. For example, you have a kind of helmet on collision. Your helmet should absorb the energy. So it can undergo fracture, no problem, but the energy should not be transferred to your skull. It is better the helmet should undergo fracture rather than your skull should go fracture. Therefore, we should not look for the kind of very sturdy helmet. Instead, it should be able to absorb it. That's what the idea. So by which we have developed a kind of a hollow structure. In case of worst case, any collision occurs, which will absorb the energy and that will not be transmitted to the kind of subject which is now housing there. So that's what the idea by which it has been developed. So therefore, no, you skip it. Go to the next slide. Last slide. I'm sorry. We took a kind of long time. We also made. Hold it. 1 minute. So I have almost sorry. We lost almost 10 minutes time. That's what I could not able to make a detailed presentation. What's the idea is we prepared some kind of innovative composite with a targeted idea. The starting one kind of fly ash filled one with the targeted idea of improved thermal resistance, improved damping capacity. We could be able to achieve them. Then again we made a kind of stainless steel wire meshed one. You cannot arbitrarily put them. You have to go for engineering them. You have to go for surface preparation, bonding them, testing them. So that could be able to withstand the kind of very impacts one. The final one, a lightweight sandwich structures, which could be used for many different normal application, even for your container boxes. Even right now, card box are being very popularly used. But if you see even your television sets or even a kind of your all the gadgets, they're coming with a kind of casing, outside casings. But if it falls down, the casing should be able to absorb energy. So therefore, some of the vital items, the outer casing could be consist of a kind of a hollow structure, but that should be able to absorb the energy. So saying from helmet or the kind of partition walls or even for automotive body panels for which the sandwich structure could be used. So like that, with the kind of some specific target, you can now develop innovative composites and to plan the experiment such a way, conduct all the experiments, get the results, analyze in a careful way, and you can now conclude them, which is the kind meeting our targeted objectives. That's what we say. Engineered composites, we say special composite, or can say the advanced composites to suit some specific requirements. This was the idea by which many number of projects are going on. So within the somewhat we exceed the time. Sorry for that. I could be able to make a presentation of 3 selective composites. So thank you for everybody. Even with a simple experiments, something you can perform such a kind of synthesizing some newer materials and we prove them, which is meeting the expected objectives. That's what the idea. So I thank once again the organizers, the principal, the direct administrator, and your chairman, all the participants and students. Wish you all the best. Thank you one and all. If there is any query, you can ask or you can send to my email ID. I can respond. If you plan the experiments, I can be able to give some kind of suggestion even later period of your research. Thank you very much for the patient listening.
Thank you, sir.
Thank you.
Sir, on behalf of Department of Mechanical Engineering, I would like to express my heartfelt gratitude for your invaluable contribution as the keynote speaker at our international conference. Your insightful and thought-provoking address has left a lasting impact on all the attendees and has significantly enriched the overall experience of the event.
Thank you.
Your expertise and passion for the subject matter were truly inspiring, and your ability to captivate the audience was nothing short of remarkable. Your willingness to share your expertise and experience has undoubtedly elevated the quality of our event, and we are immensely grateful for the time and effort you dedicated to marking and resounding the success. Once again, thank you for your exceptional contribution, and we hope to have the privilege of welcoming you back in the future. Thank you very much, sir.
Thank you very much. Thank you. Sorry for the delay. Thank you very much.
Thank you, sir.
So I leave. Okay. Any queries? Okay. No, they can send to my email ID. Okay. Thank you. Thank you. Okay.
Okay, sir.
Yeah. Shall I leave now?
Thank you, sir. Thank you.
Yeah. Thank you. Okay. Thank you.
Thank you, sir. Next, I would like to invite Mr. M. Palani, HOD of Civil Engineering, JP College of Engineering, to address the speaker.
So, good morning, all. Due to keynote speaker unavailability, we have a break for 15 minutes. The speaker will be joined on 12 o'clock. So, kindly assemble at 12 o'clock at this same link. Thank you. சார் வெல்கம் சார். சார் உங்க அன்மியூட் பண்ணல சார். மைக் இஸ் மியூட்.
ஓகே. சாரி. Thank you, sir.
Okay, sir.
Good morning.
Welcome, sir. Welcome, sir. Good morning, sir. Good morning, sir.
Thank you.
So, very good morning to all. Now, Dr. Subhas Thanapan, Professor in Civil Engineering, KAF University College. He has 23 years of experience, and abroad experience is 18 years. Ethiopia, Eritrea, and Ghana. So, educational qualification of Dr. Subhas Thanapan is B. Civil Engineering in Colombo University, Karnataka. ME in Environmental Engineering, Annamalai University. PhD in Civil Engineering, Noor Islam Center for Higher Education in 2018. His working experience: he worked 1 year in Tamil Nadu Housing Board, Ellis Nagar, Madurai Division, and he has an 1 year experience in highways, rural development in Nagarkoil. Teaching experience: 1 year in Sardaraja College of Engineering, Alangulam, and 3 years in Sun College of Engineering and Technology, Nagarkoil, and 5 years of Eritrea Institute of Technology, Northeast Africa, and 12 years of Ambo University, Ethiopia, East Africa. Now, KAF University College from August 2023 to till date. He is in member of the Doctoral Committee, Joint Integrated Multidisciplinary PhD Program, Federal Democratic Republic of Ethiopia, Ministry of Education, Addis Ababa, Ethiopia. International Association of Engineers, then International Association in Hydrological Sciences, then Institute for Engineering Research and Publications. Special roles: acting as a guest lecturer in Noor Islam College of Engineering, Nagarkoil, and he has a guest lecture in Sangar Polytechnic plus Vinayaga Mission University Collaboration, Sangar Nagar, Tirunelveli. And he is a NSS program officer at Sardaraja College of Engineering, Alangulam, Nellai district, Tamil Nadu. He has 62 research articles including SCI, Springer, Clarity, and Scopus. And he published 18 textbook, and he has 1 patent. Textbook translated and published in other languages like Spanish, Portuguese, Italian, Russian, German, and French. Professional community services completed, and an award is for collaboration with Ambo Municipality, Ambo Ethiopia, and Ambo University, Ethiopia. He includes a textbook in the syllabus of top institution in India titled Geographical Information System, Evaluation of Emission Concentrations, Publishers, Lambert Academic Publishing, Germany. Restructured the revised syllabus of postgraduate programs, Agriculture, Allied Science, Food Technology, Indian Council of Agriculture Research, New Delhi. An MTech program in Remote Sensing and GIS, National Institute of Technology, Warangal. MTech program in Artificial Intelligence, Department of Computer Science in Anandapur, India. An ME MTech in Civil Engineering, Chhattisgarh Swami Vivekananda Technical University. And the Spatial Information Technology, Vaisavi College of Engineering, Hyderabad, India. a reviewer in top reputed journals, Biomass Conversation and Biorefinery Springer Nature, International Journal of Latest Technology in Engineering, Management and Applied Science, Iranian Journal of Science and Technology, Web of Science Journal, International Journal of Research Engineering Structures and Materials, Indian Journal of Science and Technology, Iranian Journal of Science and Technology, Transaction of Civil Engineering, Springer, International Conference on Emerging Trends in Engineering and Technology, Oriental Journal of Chemistry, International Web Conference on Smart Engineering Technologies 2020, External Reviewer, Ramco Institute of Technology, Tamil Nadu, scheduled on 26 and 27 June of 2020. And other academic roles for our keynote speaker, moderator for training programs, keynote speaker, foreign examiner, international advisory committee member, advisor for postgraduates and undergraduate students, organizer ITEC events, collaboration of Indian Embassy, Adidas Ababa, Ethiopia, and Ambo University and Ambo Ethiopia. Participation and presentation in national and international conference and webinars. So thank you so much, sir, for accepting our invitation to give the keynote speaking in our international conference.
Thank you, sir. Thank you so much
now,
for the elaborate introduction on me. So I think this is my time to start, right?
Yes, sir. The time.
Yes.
Your session, sir. Can I take your own session?
Thank you, sir. Thank you so much. So first of all, good morning to everyone, especially the organizers of the ongoing conference in JP College of Engineering in Tenkasi. I'm very glad to join again. I think this is my second joining with JP College of Engineering. Hope last year also I gave one presentation to JP College. And this is my second presentation. So first of all, I am very happy because this college is located in Tenkasi, which is very close to Alangulam, where I worked or started my teaching career, of course. When I was in Alangulam, in between Alangulam and Tenkasi, there was a place, what's called the Pulangulam. In Pulangulam, I did 10 days of NSS program. Still, I remember the former president of Pulangulam Panchayat, Mr. Navanitha Krishnan, sir, and his team members. So with this remembrance, once again, I joined with JP College of Engineering to give you a nice presentation on better environmental evaluation system. So first of all, I would like to congratulate the organizers of this conference, International Conference on Science and Humanities, Building Science and Mechanical Engineering, ICSBM 2024. So when we talk about the recent technologies, okay, and the importance of the international conferences like this, which is going to help the students, especially those who are studying in JP College of Engineering, because new and professional to continue developing their skills, okay, so and their knowledge. So keeping this in mind, I chosen this topic, betterly environmental evaluation system, to deliver about it today. As we know that we are in the earth and our system is of the ecosystem, right? So the earth where we live, we all human beings, right? It is a wonderful planet. Earth has a perennial source of water to quench our thirst. So the atmosphere which supplies good air for us to breathe, right? So we have the ozone layer, ozone umbrella, which protect us from the UV rays. We have the green carpet, right? So that green carpet is of helps us to utilize oxygen. So especially we have some of the attractions like rainbow, which is of very wonder. So protecting this wonderful earth, the ecosystem is of a very important task nowadays, because air, water, and soil, these are the three basic elements which is of very important for our living condition, which must be protected whenever we involve with some of the developing project, right? Please change the slide, sir. Next slide. Yeah. So according to this slide shows that according to the United Nations World Population Dashboard, India's population is of go on increasing year by year, right? So it says that slightly over 1.438 billion. So I have shown the red symbol at the top, danger symbol. So this increase in population, which is of danger, we say that because whenever the population increases, we know that there is a need for the urbanization, development of urbanization. Okay. So whenever we think of the urbanization, there is a need of deforestation. So when the deforestation goes to urbanization, okay, or the urbanization through the deforestation, which is of resulting with pollution, very different types of pollution in different angles, which is of polluting the air, water, and soil in the form of air pollution, water pollution, and soil pollution. Next slide. So according to the recent status, the population increment in India especially. So if you see this profile shows 2010 to 2020 record. Okay, so the population is of go on increasing year by year. So this is the increment of the population we can observe from this slide. Next, please. So that the urbanization, transportation, industrialization, deforestation, even the modern agricultural activities, so all together, you can just proceed, sir. All together makes a combined effect, especially the negative impact, okay, to the society. Especially in India, the environment has become fragile and has become a major concern. So that was most of the researchers used to say that, right? So upon the urbanization or the development of transportation, or we can say the simultaneous growth of urbanization, transportation, and industrialization, which leads to certain negative impact in general. Next slide, please. Just please go ahead, sir. Next. Next. Yeah. So in the past few years, if you observe that the increase in population, as we've seen before, year by year, 2010 to 20, we have seen before. So gradually the population is of increasing, especially in India, right? So even if you take the other countries like Ethiopia, if you take in Ethiopia, for example, so in Ethiopia, there is no family planning at all, right? So every individual family, they have minimum 5 to 6 children, right? Most of the African countries, the system is like that. The number of children not restricted. They just say that it is of blessed by the God, right? So that the population increment, it is of very common in all the countries, right? So of course, India, if you take India, even though the population is of very huge, our land area, catchment area is of more and more as compared to the other African countries. So that is a main reason we are not that much affected upon it. But this simultaneous increment of population sometimes leads to the danger, because we couldn't manage the system, especially the ecosystem, in the later stage. So on right time, we had to think of how to manage the ecosystem, passing through some of the technology transfers and the new ideas, and through the certain new researches, right? So in some places of India, right, especially the agriculture, domestic and industrial sectors especially have also had a certain impact on the natural water resources of the area. Even if you see some of the river bodies around our areas, right? So most of the rivers and the pond, which is of completely collapsed, even in Kanyakumari district also, in my place also, right? So if you take the Kanyakumari district, we have plenty of water resources, right? Even Tirunelveli district, Thoothukudi district, especially the southern part of our Tamil Nadu, there is no lack for the water resources. We have the plenty of water resources, but due to the development of the agricultural, domestic and industrial activities nowadays, it becoming very danger to such water bodies. Next, please. So what we experience nowadays with the water bodies is of the main problem is what's called the eutrophication. You know about the eutrophication. Eutrophication is of the pre-aging condition of the water bodies. So mainly due to certain amount of the excess amount of nutrient-rich product like nitrogen and phosphorus, which is all generating from the industries especially. Most of the nutrient-rich product, which is of promoting the algae growth. So if you see this picture, so the water body, the pond, which is completely green in color, we cannot use it for drinking or cooking because so the condition of the water bodies are damaged. So this condition, such an impact referred to be the eutrophication. It is mainly due to the development of industrialization, not only development of industrialization, due to the development of industrialization from where the wastewater coming out from it upon the process in the form of excess amount of organic load, especially nitrogen and phosphorus. So whenever the organic load increases, as you know that the BOD, the biological oxygen demand is also increasing. Okay, so with a very high level of BOD, right, it become very danger, right? So it cannot be used for any purposes. So another major problem is of next slide. The disease, what is called the methemoglobinemia. So as we seen in the picture, this is mainly due to the excess concentration of nitrate, right? So according to World Health Organization, the nitrate, okay, it is one form of the nitrogen in water, right? So which should not go beyond 45 ppm parts per million. So if it is of greater than 45 ppm, so we could experience this kind of disease as we seen in this slide. Okay, the baby affected with the disease, what's called the blue baby disease, technically referred to be methemoglobinemia. So in addition to that, next, in addition to that, we have other impact for the aquatic life system also, which is of next slide. The damage to aquatic life, okay, the fishes will be dying, some of the valuable bacteria will be dying, so the entire water body will be of collapsed. Next slide. Additionally, we could experience some of the outdoor pollution effect, like a very common disease, what's called the asthma and the bronchial asthma, right? The respiratory problems, okay, the lung cancer. So these are all very common diseases we could experience, right? So please, next slide, please. So whenever we think of the development of new project, okay, think of the new project. So as a civil engineer, maybe after getting your graduation, you are going to become a full engineer, either in the department of PWD or highway, okay, or in the irrigation departments, agriculture department. So in whatever may be the project you are going to involve with, right? Especially for the construction of the major buildings, apartments, commercial buildings, especially for the construction of highway, railway, bridges, flyover, dam structures, some of the irrigation project, etc., especially the power plant, thermal power station, nuclear power station, right? The water supply system, wastewater supply system. So if you think of all the project, of course, there are certain advantages and disadvantages, positive and negative impacts. Okay, so some impact will be of short term, some will be of long term, some impact will be of localized impact, some will be of widespread impact, some of the impact will be of reversible impact, some will be of irreversible impact, right? So moreover, certain impact will be of existing, maybe due to the construction phase or the operation phase. Some impact would expect in future, which is referred to the anticipated impact, right? So what we say that, so considering all this impact, especially the negative impact and irreversible impact, long-term impact, okay, so we have to think of maintaining this system properly, right? So considering the water, we must assure with the water quality. Considering the air, we must assure with the air quality, okay? And about when you come to the soil condition, we must assure with the soil quality. So because the soil, air, and water, which are the basic element, okay, which is of a very fundamental need for us, right? So normally we focus on the water quality in terms of water quality index, mainly we focus on air quality in terms of air quality index and soil quality in terms of soil quality index, okay, for the health and wealth of the common society. Next slide, please. So keeping this consideration, when we think of the water quality index, we have some fundamental steps as we seen in this slide, okay. So in terms of relative weight, okay, and with the help of the quality rating scale, we can assure, right, what is the value of water quality index. So based on the water quality index, we can classify the water as excellent or good or poor in general. Next slide, please. Next, sir. Yeah, next. Yeah, so this is the table classification system. As you know that the water quality index, the importance of water quality index to classify the water as excellent, good, poor, or very poor, right? So based on that, we can decide, okay, what type of treatment to be given, okay, and what are the measures to be taken to overcome this kind of issues, especially. Next slide. So in addition to water quality index, we can think of the air quality index also, right? So in this table, it is shown with different colors: yellow, orange, red, purple, and maroon. Okay, so which is of showing the different level of the concern as good, moderate, ultimately for unhealthy for the sensitive crops, and sometimes it becomes unhealthy or very unhealthy, sometimes becomes more hazardous in nature. So all these concerns are fixed based on the value of the index, ranges from 0 to 50, 51 to 100, 101 to 150, and so on, as in here, right? So water quality index and air quality index, which is of very important concern. So whenever we think of developing a project, new project, or whenever we think of implementing a new project, right? Next slide, please. So there are 6 levels of health concern as we seen here, right? Considering the air quality index especially, right? So this we discussed already. 0 to 50 considered as good. Air quality index in the range of 51 to 100 considered as moderate, and so on. Right? So whenever we considering the air quality index of an area, there are major 8 pollutants are under consideration as listed here. Particulate matters, which is mentioned as PM 2.5, PM 10. Okay, that is the particulate matter with the size of 10 micron meter or less than 10 micron meter or less than 2.5 micron meter. In addition to that, the ozone, sulfur dioxide, nitrogen dioxide, carbon monoxide, okay, lead, ammonia. So these are the major parameters we must consider for air quality index calculation of any particular area. Next slide, please. So the next table, So the next table showing the emission rate for various sources. Especially this table was collected from, this information was collected from Central Pollution Control Board, India, their data. So for various pollutants like CO, HC, SPM, NOx, and SO2, and considering different types of fuels like coal, kerosene, wood, and LPG, right? So for example, coal is shown ton per ton, and kerosene in kg per 1,000 liters, and wood showing kg per ton, and LPG showing kilogram per 1,000 liters. So for different types of fuels, for example, by burning 1 kilogram of wood, for example, by burning 1 kilogram of the wood, according to this table, the release of carbon monoxide CO is of right, okay, for one, that is the 1 kilogram per ton. I mean, by burning 1 ton of wood, the CO generation is of 1 kilogram. So likewise, for various other type of fuels, the concentration of pollutant is also shown in this table, okay, given by Central Pollution Control Board of India. Next, please. So the next table showing that the emission rate of our Indian vehicles, especially in India, we make use of different types of vehicles like 2-wheelers, 3-wheelers, 4-wheelers, even in 4-wheelers, light duty vehicles, heavy duty vehicles, right? So upon the usage of different types of vehicles, how the emission rate is of, which is given in this table, right? Which is shown in kilogram per vehicle 1,000 kilometer. That is by operating or by running the vehicle for 1,000 kilometer distance, okay, how much kilogram of CO, HC, SPM, NOx, and SO2 will be released, okay, by the operation of either light duty gasoline powered vehicles or diesel powered vehicles or heavy duty vehicles and so on, which is shown. It is also given by the Central Pollution Control Board of India for our reference. Next, please. So in addition to the air quality as well as the water quality, mainly we had to focus on the condition of the soil. So when we think about the soil condition, okay, so we say that the main standard, what's called the irrigation standard. So the irrigation standard especially depend on the condition, what's called the salinity condition. Please make a note that the salinity condition, okay, is mainly due to the dissolved solids, especially the potentially toxic trace elements, some of the herbicides, especially the sodium level, right? So high value of the sodium in water, which is of damaging some of the sensitive crops, right? Beans, okay, the turf. So some of the very sensitive crops will be affected due to high value of sodium in water. So such a impact is technically referred to be sodium phytotoxicity. That is a very big problem. So sodium level in water, it must be controlled. So to control the sodium level, first we must ascertain what is the level of sodium in water or in water bodies, right? So it can be ascertained in terms of sodium absorption ratio, which is referred to the SAR, right? So by knowing the value of SAR, okay, we can classify the condition of the soil, whether the soil is suitable for certain type of crop or not. Especially for the irrigation activities, this sodium absorption ratio is of very fundamental. So keeping all these basic needs like air, water, and soil, okay, so thinking of air quality index, water quality index, and the soil quality index, right? So it is of our duty, especially the stakeholders. Who is the stakeholder? Stakeholders may be of engineers, right? The stakeholder may be of the project manager or the owner of the industry, right? So after getting graduation, sometimes you may become the owner for your own industry. You can start the chemical industry. You can start your own textile industry. You can start your own food processing industry. So as an owner or as any of the stakeholders, project managers or the engineers, right, or the site engineers in the construction industry, it is of our duty to protect the ecosystem, okay, maintaining the air quality, water quality, and soil quality. So keeping this as the basic okay, need and the basic information or the knowledge, we take the basic tool, what's called the EAA and BEES. Now I come to this point. What is EAA and what is BEES? So you know that EAA means environmental impact assessment. BEES, that is Battery Environmental Evaluation System, right? So I shortly say that BEES is a part of EAA. We know that environmental impact assessment is of the basic tool. It is of the basic tool, especially whenever we thinking of, proposing a new project, during the planning stage itself, we involve with environmental impact assessment. Almost 29 countries, including India, China, okay, Canada, okay, New Zealand, Australia. So most of the countries, more than 29 countries, they are following the system or they make use of EAA tool. Because EAA is of implemented usually during the planning stage itself. So whenever they think of starting a new project, sometimes maybe the expansion of the road, highway, okay, or for the construction of the dam structures in a new area, new locality. So the EAA must be done in the planning stage itself. So EAA, environmental impact assessment, okay, focusing on air quality, water quality, and soil quality, mainly the existing condition of air, the existing condition of the water, the existing condition of the soil must be ascertained. So through the environmental impact assessment, so it is the duty of the stakeholders, okay, to identify all the negative impact, all the irreversible impact, okay, all the long-term impact. So it must be identified before they are implementing certain project in a particular locality. So for that purpose, okay, especially for analyzing the existing environmental condition, what is the condition today? What is the existing condition today? What is the climate condition today? What is the weather condition today? Okay, so to analyze about the existing condition of today, okay, this EIA and BEES, which is of very important, very fundamental tools. Next, please. So the Betterly technique. So this is of the environmental evaluation system, Betterly environmental evaluation system, BEES. So we could say that it is a methodology for conducting the environmental impact analysis or the environmental impact assessment, which is developed at Betterly Columbus Laboratory in US. Okay, so by an interdisciplinary research team under the contract okay, with the US Bureau of Reclamation. So BEES especially is a scientific technology. Next slide, please. Scientific technology was implemented to ascertain the environmental quality in general. So considering the air quality, next slide, please. Yeah. So, okay. So considering the air quality, it is of very important to ascertain the existing condition of CO, carbon monoxide, hydrocarbon, SPM, okay, nitrogen oxide, particulate matters, right? So similarly for the water quality, it is of essential, the existing condition of pH, water pH, okay, the nitrogen concentration, nitrate concentration, right? So the BOD level, COD level. So all the fundamental properties must be identified through this mechanism. So the widely used BES, okay, so mainly for water resource planning, air quality determination, groundwater analysis, and for the evaluation of the project impact to select specific alternatives. So we say that certain specific alternatives. So let me give you a small example that, so even in our southern part, especially in Thoothukudi district, I think so, right? I think, yeah, Thoothukudi district, Kudangulam. So in Kudangulam, we have the power station, right? That nuclear power station. So in other region, we have in Neyveli, you have the thermal power station, thermal power plant. So even if you consider the thermal power plant especially, so the basic raw material what they are using is of coal and the oil. So by burning the coal or the oil, what we produce is of electricity, right? So that is the positive impact. So in addition to this positive impact, from the same plant, what we experience, the negative impact is of the excess amount of the generation of fly ash. So the fly ash generation, okay, so that is the main problem what we in the past days we experienced in Kodangulam also. So the excess amount of the fly ash, especially the toxic substances, not only fly ash, the other toxic substances also, it is of mixing with the water bodies, especially the nearby sea, in the ocean. So we have seen some days there were some violences had occurred, right? So a team of people, they were opposing against the project, the nuclear power station, which is established in Kodangulam area, right? So to overcome this kind of issues, the later issues, it is of very much essential during the planning stage itself, okay, to identify all the major impact and to fix some of the alternatives, specific alternatives to overcome the future issues or the negative impact. So it should be done in the planning stage itself. So to conduct the EA study, what I say that this Betterly environmental evaluation system is of very much important. So which can help EA study, okay, to get a better alternatives, specific alternatives in general. Next, please. So it is very clear that BES is for EIA, the environmental evaluation system. It's a Betterly environmental evaluation system is purely as a methodology for conducting environmental impact assessment. Next. So environmental impact scores developed in the EES are based on the magnitude of specific environmental impact and their relative impact. I can show some of the examples in the next slide. Next, please. So the major output from the EES is an indication of major adverse impact called the red flags. So which are of concern of and by themselves. So these flags indicate fragile element of the environment. Okay. So how we can fix the parameter index that we can see in the next slide. We can move to next slide, please. Next, please. Next. Yeah, let it be. Yeah, let it be, sir, before. So in BES, okay, so we consider 78 measurable environmental parameters. Of course, it is divided into 4 major categories as seen here: ecology, physical and chemical, aesthetic, okay, and the human interest and social. So we have seen 4 broad categories, okay, in which this EES system can be handled, right? So this BES identified a total of 4 categories, 18 components, and 78 parameters. Next slide. So these all categories are divided into the thematic data, right? So those thematic data are divided into environmental indicators. For example, as shown here, the sugar industry. You know about the sugar industry. So the sugar industry, where the production of the sugar, okay. So the sugar industry especially, okay, they make use of certain quantity, a huge amount of water for the production of the sugar, right? So whatever the amount of water used by them, which may be considered 100% of water used. So out of 100% of water used by them, so the most of the report says that 85% of water used by them turning as the wastewater, right? Wastewater with a very high level of BOD, okay? So inflexible level of suspended solid, COD, certain amount of oil and grease, total dissolved solids, and so on. So it's a very high level of BOD, organic load, okay, which is of the danger if it is of directly diverted to the water bodies like river or the pond or the lake or any other water bodies. Okay, so it is of very important to identify the environmental indicators as we seen here. What is the level of BOD? What is the level of pH? What is the level of COD? What is the level of oil and grease? What is the level of TDS? It must be ascertained by that particular industry or the stakeholder of those industries using this system, what's called the BEES. Next, please. So once the environmental indicators are chosen, okay, so we can follow up with the remaining steps, step 1, step 2, and step 3 as in here. So at the first step, at this stage, the goal of the method is to transform environmental indicators into environmental quality. The notation table defines actually the range which is shown from 0 to 1. Of course, the 0 which indicate the poor quality, okay, 1 indicate good quality. So that is the environmental indicator, indicating directly the condition of water or the air in terms of environmental quality, right? The second step, a total of 1,000 points. What point? Point is referred to the parameter importance unit, simply referred to the PIU, which is shared among all the indicators that I can show in the next slide, right? So they reflect the relative importance of each parameter. For example, for pH, there is a parameter importance unit. For BOD, there is a value of PIU, which is already assigned by Betterly Lab of Colombo in US. So they have given us the PIU values for all the fundamental parameters. Okay, so the overall PIU values of considered as 1,000 points. That must be noted. That the comparison between the decision and the help of the term what's called the environmental impact unit, EIU. So by knowing the value of EIU, environmental impact unit, we can compare what is the level of impact before and after the implementation of the project, right? So before construction of the dam structure in a locality or after the construction of the dam structure in a locality, or before the expansion of the road, or after the expansion of highway, right? So considering any of the project before and after, or with or without the project, right? So we can ascertain or we can compare the situation, how it is of existing. That is of the most advantages upon this particular tool. Next slide, please. So now when we come to the PAU, the parameter importance unit, okay, so it is a certain weighted factor with respect to the importance of the impact and the magnitude of the impact, right? So for example, if you take the water sample, so in water sample from the river or sorry, because no, the pronunciation I use the river because here in Africa we are not saying river, that or is of silent. So sometimes in my pronunciation is of continuing. So in the water bodies in river, when we collect the sample, okay, sometimes due to the industrial activities, the BOD level, the organic load will be of very high, and the nitrate concentration will be of very high. So considering BOD, nitrate, okay, pH, so some other parameters, so we can fix, okay, we can fix the PAU depend on, as said, the importance of the impact. For example, BOD, nitrate. So these two, if you consider, which is of very important in term of impact. Okay, high load of organic load is also high level of impact. The high level of nitrate is also reflecting with high level of impact. So we can fix 5. The PAU can be of, or the relative weight can be fixed as 5. But considering the other parameters like pH, the effort is or the impact is of comparatively less. So we fix the relative weight as 3 or 2. So based on the parameters and their impact for the society, the impact for the water bodies and so on, we fix the relative weight. Accordingly, the parameter importance unit is fixed by them. Thank you. So a total of 1,000 PAUs I told, right? So considering all the fundamental parameters for soil, water, the air, okay, air quality parameters, all together, okay, the total PAU is fixed as 1,000 by them, by Columns Lab of Batele, right? Which is distributed among 78 parameters based on value judgment, okay, the one. So to what level the BOD is of impact? Level, so the parametric estimate must be converted into the environmental quality scale that ranges from 0 to 1. If the value of EQ equal to 0, which indicate the environmental quality is of extremely bad. So 0, next slide please. Environmental quality, if it is of extremely 0, it is of extremely bad. Next slide please. And if the value of EQ is of 1, as I told, environmental quality is of very good. So the range is of 0 to 1 only. 0 indicate very bad quality, 1 indicate very good quality. For example, if it is of 0.5, we can say it is of 50% moderate. Okay, so like that we can decide. Please, next please. So this is the table showing okay, the various components for all the 4 categories as we listed before, including ecology, okay, pollution, aesthetics, and human interest. So for the first category of ecology, we had different components and various parameters. So for every individual parameters, you can see the parameter importance unit, PAU values was shown, right? So for example, if you take species and population, number 9, sport fish, the assigned PAUs of 14. So all the assigned PAUs are shown in this first table. Next, please. And when you come to the pollution category, water pollution, soil pollution, and so on. So under the water pollution, we have seen different parameters like BOD, dissolved oxygen, right, pH, pesticide, temperature, turbidity, toxic substances. So for every individual parameters, they have assigned, right, the PAU value as 20, 25, 31, 18, and so on. Even when you come to the air, So when we involve with the air quality index, air quality determination, we can make use of this table, okay, and the PAU values assigned here for carbon monoxide, hydrocarbon, nitrogen oxide, and so on. Okay. For example, carbon monoxide, the PAU is fixed as 5. For hydrocarbon, the PAU is fixed as 5. For nitrogen oxide is 10, right? So particulate matter is of 12. So make a note that if you take carbon monoxide, hydrocarbon, nitrogen oxide, and particulate matter is the dust in the form of cement particle or right, any of the dust particle or the cement particle, fly ash, which is of microscopic in size. So those particle which is of microscopic in size, which is of giving the more negative impact. Okay. So the maximum PAU values are given for particulate matter as 12 as compared to the other matters like carbon monoxide and so on. So based on the impact to the society or to the human being or to the water bodies, all these PAU values are fixed by them. So if you add all the values under all the categories, all the 4 categories for all the parameters, totally you are getting 1000 PAU. Okay, next slide, please. Next, please. So the BES is of the scientific technology, we could say that, which was implemented to ascertain the environmental quality of the study area, okay, based on the total emission concentration in terms of CO, HC, SPM, NOx, and SO2. So according to BES USA, the assigned parameter important unit for various gaseous pollutants, okay, so which was shown in the next table. Please come to the next slide, please. Yeah, in this table, it was summarized, okay, especially for CO, HC, SPM, NOx, and SO2. The assigned PAUs are given as, right, for carbon monoxide 5, hydrocarbon 5, PM 12, nitrogen oxide 10, and so on. So we can make use of this assigned PAU value, okay, to calculate the environmental quality index in general. Next, please. So mathematically, it is represented as the sum of EAU, that is environmental impact unit, okay, which is equal to sum of environmental quality considering all the individual parameters, where small I is of the individual parameters, right, multiplied by parameter importance unit minus the sum of environmental quality of individual parameters, okay, multiplied by the parameter importance unit. So EAU is of the environmental impact unit. EQI, that is number 1, that is environmental quality for indicator, any indicator, maybe pH or BOD with the project, okay. And the second, number 2, EQI to indicate without project, with the project and without project, or before implementation of the project or after implementation of the project. So based on that, the environmental impact unit is of calculated in terms of parameter importance unit. Next, please. So in this table, you can see the environmental quality score. Okay, environmental quality score, it shows 0 0.1, 0 0.2, 0 0.3 up to 1. So 0 to 1, the range of 0 to 1. So the environmental quality, if it is of 0 0.1, it is classified as unacceptable. If it is of 0 0.5, it is declared as bad quality, right? If it is of 1, it shows that it is of excellent quality. So by knowing the environmental quality score, we can conclude whether the quality of water is good or bad, whether the quality of air is of good or bad, whether the quality of soil is of good or bad, it can be decided. Please, next please. So I have shown some of the examples here. So this is first example considering the BOD, right? So for BOD, as per the determination, right, we know that according to the World Health Organization, especially the Bureau of the Indian Standard, BIS, according to the BIS, the maximum permissible limit of BOD for drinking and bathing are given as 2 milligram per liter and 3 milligram per liter respectively. So in one particular study, it was observed that from the river body of Lakshman Tira and lake 1 and 3.1 respectively. especially the river body, the BOD value was measured as 1 milligram per liter. 1 milligram per liter. So of course it is of less than 2. So we can say that the quality is of acceptable, right? So based on the environmental quality score, we can decide whether it is of acceptable level or not. So in the second example, please next, which is of showing with the parameter was called the pH for the water, right? So in this case, considering, upon the observation of the value of the pH value for the water sample, the environmental quality was fixed as 0.8, 0.8. So 0.8, almost close to 1, we can say it is of in good condition or in very good condition, right? So in terms of pH, it is of good. So likewise, for any parameters for water or air or the soil, we can find out the environmental quality score using the BES system, and we can decide the quality about it. Right? Next, please. So likewise, I have shown another example, example 3 on TDS. Okay, TDS. So for example, if you take this example according to ISI standard, okay, the TDS range should range from 500 to 3000 milligram per liter. That is of the acceptable limit. So in the study with some water sample, it was observed that 500 milligram per liter. So the resulted values of 500 milligram per liter. So which is when you compare with the ISI standard, it is of the lower level. So UK is of well and good. So the quality in terms of TDS for water, it is of in excellent condition. So likewise, we can decide. Next, please. So likewise, for various attributes, BOD, pH, total dissolved solid, nitrate, we can fix the EQS, environmental quality score, okay, like 0.5, 0.8 or 1, okay. And we know that the PAU, parameter importance unit, already prescribed by the column slab of Battley in US. So we can select that value. For BOD, according to them, the PAU fixed is of 25, for pH is 18, for TDS 25 and nitrate 25. So all the PAU values are selected from that table, previous table, which is given to us by the Battley column slab of ESA. Just we follow it. So by knowing the environmental quality score and the PAU, we can calculate environmental quality index, which is shown in the last column. Environmental quality index, EQI. That is the product of these two, EQS multiplied by PAU, which directly give you EQI. So that is 0.5 into 25, 12.5, 1 into 25, 25, and so on. Thank you. Next. So by knowing the environmental quality index of the previous table, when we come to this table, okay, for example, we can directly classify if the environmental quality index is of 0 to 25, okay, the corresponding environmental ranking classification source, it is of poor. And the environmental quality value, it is of 26 to 50, we can classify it as satisfactory. 51 to 75, we can classify it as good. 76 to 100, we can classify it as excellent. So likewise, we can directly classify based on the environmental quality index. Okay, so for that, this parameter importance unit is of very much essential. That's the reason we are following the BES system. Okay, so by adopting the Battley technique, next, the environmental quality index can be calculated as we seen, okay, by taking the product of EQS and PAU. Next, please. Next. So the environmental quality index, for example, if the ideal dissolved oxygen in the stream, if it is of 9 milligram per liter, I came to next slide, sir. And the effect of the proposed action is to lower the dissolved oxygen to 3 milligram per liter. The ratio would be of 0.33. So this is usually called the environmental quality index. So this is the one shootable example I shown here, right? So the environmental impact unit, as you noted, the product of UK and PAU, right, is the magnitude of the impact multiplied by the importance. Come to the next slide. Next, you can pause 2 slides. So for example, I have shown some of the sample here. Sample 1. So this is the sample 1, the environmental category wise result of environmental impact due to Sri Mahankali sugar industry. right? So this is the report I collected from the report of them, right? So this report given by Sri Mahankali sugar industry. So upon following this BES system by them, by the stakeholders of that industry, for the various categories of ecology, environmental contamination, aesthetics, and human interest, okay, they have fixed the PAU values and they have fixed the EAU, right? So based on that, they have ascertained the quality of the wastewater generating from that particular industry. Next, please. So this is the sample showing the degree of environmental impact obtained from one particular basin, Bahana basin. Next. So when we think of the emission inventory for ascertain the air quality, or when we think of the water quality index or the soil quality index, as we discussed before, so the battery system becoming the valuable tool in general, right? So we can pause to next two slides, sir. Can pause. Next. Next, please. It's already discussed. Yeah. So yeah, please come back. One slide back. Yes, sir. So here I have shown a small example how we calculate the quality. One more example I have shown. So right. So this is of the stream. I mean the river body. So in this example, PAU is of used as 10 and the linear function for EQI, right? So some of the parameters are taken under consideration: the appearance of water, the suspended solid, odor, aquatic life, and dissolved oxygen. So keeping all these items, okay, before the construction of the project and after the construction of the project. So keeping these two condition before the project, condition after the project, the EQI, environmental quality index, is of calculated, okay, from which the environmental impact unit can be calculated, so to ascertain the nature. Next slide. So the next slide, I have shown the complete calculation condition before project, after project with EQI value. For example, appearance of water. Condition before project, it is assigned 10 points. Condition after the project, maybe some industry, that particular industry, okay, appearance of water is of 3. So it is well noted that before the construction of the project or before the existing of the project, right, execution of the certain activities, right, the appearance of water in the water body is of 10. 10 is of high value. But after the construction or after the implementation of the project, the appearance became less. Quality became less appearance wise. The value assigned is of 3. So, okay, 10 and 3 before and after the project. Okay, so the EQI is taken as 3 by 10, which is 0.33. Similarly, for suspended solid, before 10 milligram per liter, by testing the water sample in the river body, the suspended solid concentration is of 10 milligram per liter. But after the implementation of certain projects nearby industries, right, due to some of the entry of the suspended solids, now it has been increased to 1000 milligram per liter. Okay, 10 has been increased to 1000 milligram per liter. So the EQI is of taken as 10 by 1000, that is 0.01. Likewise, for various other items like odor, aquatic life, dissolved oxygen, okay, the EQI is of calculated, right? So now we make use of PAU, parameter importance unit, which is shown in the bottom table for those parameters. So all these PAUs are given by the column slab of battery. We make use of it, especially for the appearance of water. PAU assigned by them is of 1. You can refer that table. It is of standard 1. Suspended solid, it is standard according to them. It is 2. Odor is 1. Aquatic life 5. Dissolved oxygen 1. Okay. So here in this category, now we have totally 10 PAUs totally, right? So appearance of water, PAUs of 1, which is multiplied by its EQI at the top table. So 0.33 into 1, it is of 0.33. So likewise for all the items, we just multiply PAI and EQI. So we get the total EAU, So in this case, it is of 2.73. So by knowing the environmental impact unit, the main advantages of, okay, by knowing this value, okay, we can think of certain alternatives. Okay, so the total EAU for any action, each action, it can be compared to each other. Okay, so the better action is of indicated by the high EAU. I mean, if the EAU values of very high, okay, if the EAU values of environmental impact unit is of very high, so the action required is of to high level. So specific alternatives must be implemented, identified and implemented. Some alternatives must be incorporated in the developing project. So that is the very important logic of ascertaining EAU in terms of PAU values given by the battery environmental evaluation system. Okay. So normally this next we can pass. This BE technique in battery, they weighted to different parameters of based on Delphi techniques, whatever we seen, the PAU values. Okay, so all the PAU values were fixed by them upon the method what's called the Delphi method, Delphi technique. So this Delphi technique, next sir, which is of initiated in the year 1960. So following the Delphi method only, all the PAU values were fixed by this particular organization of ESA. Right. Next, sir, next. So as we noted, okay, upon this discussion, especially these BES, we come to last slide, so last advantage and disadvantages. So BES is of having certain advantages and certain disadvantages. So which are highlighted in the next slide. Next, please. So when you come to the conclusion, we can see what are the basic advantages and disadvantages. Number one, the main advantages, number one, the battery technique can be easily used for the study considered in the scope of study, especially for EAA. Next, please. Next. Yes. So these are the major advantages of BES, right? Mainly, as I told in the beginning, environmental impact assessment is of very basic and very important. It is a mandatory tool for any of the developing project. So EAA must be conducted in the beginning stage, during the developing stage, okay, of any project, maybe cement industry or for the construction of dam structure or for the construction of a flyover or the bridges, okay, or the thermal power station or the nuclear power station. So it must be during the planning stage itself, EAA must be conducted through the public participation and the community engagement. Okay, so for example, as a part of EAA, public hearing and the community engagement is of very important. So no government or no organization, even if you take municipality or the government organization, they cannot initiate any project all in sudden. Even if they think of expanding a road, for example, if you know that in Kanyakumari district, Martanda flyover. So when the government was initiated the project of the construction of the flyover at Martanda, so even from the public, there were some different opinion from them. Even for the construction of the flyover, it was not initially accepted by the people, because due to the construction of, once if the project is implemented, definitely the business will be affecting to them. So most of the business people, they were opposed for the construction of the flyover, you note that, right? So whenever the government is thinking of developing a project, during the planning stage itself, they should call the public, the business people, okay, the farmers, so to inform them about the development project or the proposed project. So, okay, so in that public hearing, they must point out all the importance, okay, of the project, about the specific alternatives and so on. Okay, so for that, this BES is of very much important, right? So the principal advantage of this method is that it gives a comparative analysis, as we've seen before, between the several situations before construction or after construction. So before implementation of the project or after implementation of the project and so on. So in general, we can say that if you go through these advantages, no, it is a very flexible. The system is of very flexible. It is of less theoretical part. Okay. So the mathematical calculation is also very less. Okay. It is more flexible in general, so that we can make use of this BES for our developing project in general. Of course, there are certain disadvantages. Okay. So the result of EA depend on experts' judgment, because especially the PAU is of fixed by them on judgment. So we cannot say it is of very accurate, but more or less it is of considerable. So although there are certain few disadvantages, the advantages are more. Okay, so we have seen 9 advantages, but disadvantages of very few. So we can make use of this BES system for our developing project. So I hope this session, what I explained here about the BES system, it will be more helpful for you in future. Even when you, maybe some of the students may be of the final year, during your final year project, you can make use of this tool. Okay, your final year project, maybe in the UG level or in PG level, right? Or when you join some job in the construction industry or in other organizations, okay, not only in civil engineering, even in the mechanical engineering field, electrical engineering field, okay. So you can make use of this particular tool, okay, to overcome all the negative and irreversible impact in general. So, okay, so for getting more details about this BES system, you can refer some of the references which I highlighted in the next slide. Please, sir, next slide. Some references and certain publications. Okay, next slide, please. So there are a number of papers, articles we can find through Google, where this BES system is of implemented. So even myself, I have published a few articles, okay, and which is of indexed in Scopus. We can refer those journals and publications for your future reference. I hope this system is of more helpful and we can make use of it for your future implementation of any of the project. Okay. So thank you so much. Once again, I thank all the members and especially the students for your patience and given the chance for me to deliver about the system. So once again, thanks to the organizers. Thank you so much. If you have any queries, you can raise, please. It's time for you now. Thank you, sir.
Thank you, sir. Thank you so much for your presentation about the environmental piece. Students, if you have any queries, please ask your questions.
Are they from civil engineering or different disciplines?
Civil, Mech, and Science and Humanities, sir.
Civil,
3 departments are available.
Okay.
The 3 departments jointly organize this international conference.
Very good event. Yeah.
Okay, sir. So thank you, sir.
Please come out with different technology transfer. Okay, not only this BES. Okay, so on your discipline, if you have civil engineering field or mechanical or electrical, you can think of some of the technology transfer. Please try to bring out the technology transfer and implement or incorporate in your next coming project. So you had to think of the green environment. That is very important, because nowadays the pollution is a very big problem, especially in India, right? So our generation, even the next coming generation, should be protected. It is our duty to the maximum highlight on the environmental protection. Please come out with some of the technology transfer to support our future. Thank you so much.
Thank you, sir. Thank you so much. Surely we will save our environment due to our students as well as our public.
Yeah, yeah. So not only this one, even we can think of some of the project. I mean, let me conclude with this one, if you have the time, please. Even especially in Ghana, we have the some area we have the cultivation of the cashew nut. The cashew nut, it is a highly valuable product. But the cashew nut apple, the apple, sort of that kollapalam, Tamil. Cashew nut apple. That apple portion is of totally becoming the waste product. So we make use of only the cashew nut, but the apple is of the waste product. So we can make use of the cashew nut apple, okay, to reproduce some of the valuable items, right? Okay, like the jam items, apple jam, okay, or some of the other eatable items. So regarding this, of course, recently we had the discussion with Vellore Institute of Technology, Vellore, with some of the professors. They have implemented this project by them in Vellore Institute of Technology. So likewise, we can think of some of the developing projects, some of the technology transfer to make use of some of the new ideas, okay, to protect the environment, for the recycling, reuse of certain valuable product, and so on. So with this, I conclude myself. Thank you so much once again. Thank you.
Thank you, sir. Thank you. On behalf of Civil Department and JP College of Engineering, I would like to express my heartfelt gratitude for your invaluable contribution as the keynote speaker for
Thank
our international conference. Your expertise and passion for the subject matter were truly inspiring, and your ability to captivate the audience was nothing short of remarkable. Once again, thank you for your exceptional contribution, and we hope to have the privilege of welcoming you back in the future, sir. Thank you so much.
Definitely, sir. Thank you so much. Thank you, sir. Thank you once again.
Thank you, sir. Thank you.
Thank you, everybody, students. Please, thank you.
Thank you, sir. The morning session have come to an end. Thank you all for your cooperation and support. Paper presentation will begin sharply at 1:45 p.m. Participants are requested to join using the respective links. Thank you all. Wish you all the best.